Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. When launching an EC2 instance, three foundational building blocks come into play: the Amazon Machine Image, AMI, the root device where the system boots, and the data storage that supports workload performance. These elements work together to define not only how an instance starts, but also how it behaves under load and how data is preserved or discarded. AMIs provide the operating system and configuration template. EBS volumes deliver persistent, durable storage. Instance Store offers ultra-fast, ephemeral disks for workloads that can tolerate data loss on termination. For learners, it helps to imagine setting up a new computer. The AMI is the pre-installed operating system, EBS is the hard drive where files survive power cycles, and Instance Store is the scratchpad that clears itself when the machine is turned off. An AMI is essentially a blueprint for creating an EC2 instance. It bundles an operating system with pre-configured software, settings, and sometimes even application code. AWS provides baseline AMIs for common operating systems like Amazon Linux, Ubuntu, or Windows. The AWS Marketplace extends this by offering third-party AMIs preloaded with commercial applications such as firewalls or databases. Many organizations also build custom golden AMIs, hardened and patched images tailored to corporate standards. Beginners should picture AMIs as house floor plans. AWS offers starter homes, vendors offer designer models, and enterprises draft their own blueprints to match specific needs. Every AMI is scoped to a region and identified by a unique ID. This means an AMI created in one region cannot be used directly in another unless copied. Sharing is also supported, either publicly or to specific accounts, enabling collaboration or distribution across teams. Beginners should see this as building codes in different cities. A floor plan in one city must be adapted before construction elsewhere. On the exam, this detail often appears in scenarios requiring cross-region or cross-account deployment, highlighting the importance of understanding AMI scope. Root device types in EC2 fall into two categories: EBS-backed and Instance Store-backed. With an EBS-backed root device, the operating system resides on an EBS volume, offering persistence even if the instance is stopped. With Instance Store, the root device resides on ephemeral local storage tied to the life of the instance. Beginners should imagine laptops with SSD drives versus whiteboards in a meeting room. Laptops keep information even when powered down, while whiteboards are erased once the meeting ends. Choosing between them determines whether an instance's operating system and data survive restarts. Amazon Elastic Block Store, or EBS, is the primary persistent block storage service in AWS. Volumes are network-attached to instances, behaving like traditional hard drives that can be formatted with file systems or databases. EBS volumes are independent of EC2 lifecycles, meaning they persist beyond reboots or instance terminations. For learners, think of EBS as an external hard drive plugged into a computer. Even if you replace the computer, the drive and its contents remain. This persistence makes EBS the go-to choice for critical workloads where data durability is essential. EBS offers multiple volume types optimized for different workloads. General-purpose GP3 volumes balance price and performance, serving most applications. Provisioned IOPS volumes IO1 and IO2 provide guaranteed high I/O rates for databases and transactional systems. Throughput-optimized Street 1 volumes handle large sequential reads and writes, such as logs or streaming workloads, while cold storage SC1 targets infrequently accessed data at low cost. Beginners should think of these as vehicle types: sedans for daily use, race cars for performance, trucks for heavy hauling, and storage lockers for rarely accessed items. The exam often tests whether you can align the workload to the correct volume type. IOPS and throughput are two critical metrics when sizing volumes. IOPS, or input/output operations per second, measures how many small operations can be handled quickly, while throughput measures how much bulk data flows in a given time. Workloads like relational databases rely on high IOPS, while big data ingestion leans on throughput. Beginners should picture this as comparing a turnstile to a wide gate. One is designed to handle many people quickly, the other to move fewer but larger groups at once. Recognizing which bottleneck matters most is key to effective EBS planning. Snapshots provide backup in recovery for EBS volumes. These are incremental, meaning only changed blocks are saved after the first snapshot. Stored in S3, they offer durability and the ability to restore volumes in the same or different availability zones. For learners, this is like versioned photocopies of a manuscript. Instead of copying the entire book every time, you only duplicate the new pages. Snapshots allow quick rollback, disaster recovery, and replication, making them a cornerstone of data protection strategies in AWS. Encryption is built into EBS with server-side encryption using AWS KMS keys. This ensures data at rest, data in transit between the instance and volume, and even snapshots are protected. Beginners should see encryption as a lock on every hard drive, cable, and backup file. The data remains secure even if intercepted or copied. On the exam, remember that EBS encryption is seamless, supported natively without performance penalty, and integrates tightly with AWS KMS for key management. Fast Snapshot Restore, or FSR, enhances recovery by ensuring new volumes created from snapshots are immediately performant. Without FSR, volumes may require initialization before reaching full speed, a process that can delay recovery. Beginners should think of FSR as preheating an oven. With it enabled, the system is ready to bake instantly instead of waiting for the temperature to rise. FSR is especially valuable for disaster recovery, where every second of recovery time matters. Instant Store provides an alternative, ephemeral NVMe SSD storage directly attached to the host server. This local storage offers blazing speed but disappears once the instance stops, terminates, or fails. For learners, this is like scratch paper during a math test, perfect for quick calculations, but not for keeping permanent notes. Instant Store is well suited for temporary caches, high-performance scratch space, or workloads designed with replication so that data loss is acceptable. Its speed is unmatched, but its impermanence must always be factored in. Understanding persistence differences is crucial. An EBS volume remains even if the EC2 instance is stopped and restarted, while instant store data vanishes if the instance is stopped or terminated. Beginners should picture this as comparing a USB stick to a chalkboard. One keeps its data even when disconnected, while the other wipes clean every time you reset the room. On the exam, questions often test this distinction, asking whether a given workload should use EBS or Instant Store. Device mapping in EC2 allows administrators to attach or detach multiple EBS volumes to a single instance. Each volume can serve different roles, such as separating logs, application data, and root devices. Limits depend on instance type, but flexibility ensures workloads can scale horizontally across volumes. Beginners should think of device mapping as assigning multiple drawers to a desk, one for supplies, one for files, and one for personal items. Mapping keeps workloads organized and allows better tuning for performance and durability. Performance tuning with EBS and Instant Store may involve RAID configurations, queue depth adjustments, or proper block alignment. For example, striping across multiple EBS volumes can increase throughput. Beginners should picture this as widening a highway by adding extra lanes. More cars can travel smoothly if traffic is distributed. AWS provides these tuning options, but they must be used carefully. balancing cost and complexity against performance gains. From an exam perspective, the critical distinction is knowing when to choose EBS versus Instant Store. If durability, persistence, and backups are required, EBS is the right answer. If ultra-fast but temporary storage is acceptable, Instant Store may be ideal. Beginners should remember the key phrase. Data persists if instance stops points to EBS, while data lost on stop or terminate points to Instant Store. This simple rule helps clarify many exam questions about EC2 storage. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Many organizations standardize their environments by building golden AMIs. This pipeline begins with a base operating system image, which is then patched, hardened, and loaded with required software agents such as monitoring or security tools. After validation and testing, the AMI is distributed for developers and operations teams to use consistently. The value of golden AMIs is repeatability. Every new instance launched from the image inherits the same trusted configuration. Beginners should imagine baking loaves of bread from the same batch of dough. Each comes out uniform, predictable, and ready to serve. In cloud environments, golden AMIs reduce drift and ensure compliance across fleets of instances. AMIs can also be shared and copied. Sharing may be restricted to specific AWS accounts, which is useful when different business units need to launch consistent environments. Copying AMIs across regions supports multi-region architectures, enabling disaster recovery or global scaling strategies. This flexibility allows organizations to replicate standards wherever workloads need to run. Beginners should think of this as photocopying blueprints. The same design can be built in multiple cities, adjusted only for local conditions. The key lesson is that AMIs are not global by default, but they can be extended through careful management. Snapshots form the backbone of data lifecycle management in EBS. Organizations often create lifecycle policies that automatically snapshot volumes on schedules, daily, weekly, or monthly, and expire older snapshots after retention periods. This controls both compliance and cost, ensuring recovery points exist without indefinitely paying for stale backups. Beginners should see snapshots like saving drafts of an essay. You keep recent versions for editing but discard very old ones that no longer matter. Without lifecycle management, snapshot sprawl can quietly inflate storage bills while adding little value. Understanding backup consistency is essential. Crash-consistent backups capture data as it exists at a moment in time, potentially mid-transaction. Application-consistent backups, by contrast, coordinate with applications to flush caches and complete operations before capture, ensuring clean recoveries. Beginners should see this as photographing a desk. A crash-consistent shot may catch papers mid-scatter, while an application-consistent shot waits until everything is neatly filed. The exam may highlight this distinction, and in practice, mission-critical databases nearly always demand application-consistent approaches. Restoring data from snapshots is straightforward. A new EBS volume can be created directly from a snapshot, attached to an instance, and mounted for use. AMIs can also be generated from snapshots, allowing entire machine images to be built on top of stored volumes. This flexibility ensures snapshots are not just backups, but also templates for rapid recovery and scaling. Beginners should see this as pulling copies from a master negative. You can make fresh prints on demand, each faithful to the original. Recovery is fast and predictable when snapshots are leveraged well. Encryption adds another dimension of control. EBS snapshots and volumes can be encrypted with AWS KMS keys, but governance requires careful key policy design. Sharing snapshots across accounts requires granting the receiving account permission to use the associated KMS key. Beginners should picture this as locking boxes with combination locks. The box and the key must travel together. Without key access, the snapshot is unreadable. Cross-account encryption therefore depends on aligning KMS policies with snapshot permissions. Performance-intensive applications sometimes require more than baseline throughput. Provisioned IOPS volumes, such as IO2, deliver consistent high-performance storage that scales into hundreds of thousands of IOPS. This is critical for enterprise databases or trading systems. Additionally, some instance types provide enhanced EBS bandwidth, ensuring the network path to volumes does not become a bottleneck. Beginners should think of this as widening the pipeline between storage and compute. Even the best disks are wasted if the road to them is narrow. Aligning throughput, IOPS, and instance bandwidth avoids these hidden choke points. For temporary data, Instant Store remains useful. When workloads generate scratch files, caches, or ephemeral buffers, Instant Store provides high-speed NVMe access without the overhead of persistence. The caveat is that applications must checkpoint progress elsewhere, often to EBS or S3, in case of interruption. Beginners should think of this as working on a chalkboard, fast and flexible, but erased once the session ends. Architecting for Instant Store means assuming data loss is inevitable and planning accordingly. Boot times can also be influenced by storage design. Large AMIs take longer to initialize, while enabling fast snapshot restore reduces warm-up delays for new EBS volumes. Warm pools of pre-initialized instances can further shorten startup time in auto-scaling groups. Beginners should see this as preheating ovens before a dinner rush. Food cooks faster when the environment is already warm. For latency-sensitive systems, optimizing AMI size and leveraging FSR can mean the difference between sluggish and seamless scaling events. Compliance requires treating AMIs and snapshots like governed assets. Tagging images with metadata such as owner, purpose, and expiration dates ensures visibility. Retention policies prevent outdated or insecure AMIs from being used. Beginners should compare this to a library catalog. Without proper tags, books become hard to track, and outdated editions might be handed out by mistake. Compliance frameworks often mandate that images be patched regularly and tracked carefully, reinforcing the need for governance around AMI and snapshot usage. Monitoring storage is another critical discipline. CloudWatch metrics expose volume performance, including IOPS, throughput, and burst balances. These signals reveal whether workloads are saturating their volumes or if bottlenecks exist. Beginners should picture car dashboards showing speed and fuel. Without metrics, you can't know if the engine is straining or cruising comfortably. Monitoring ensures storage decisions remain aligned with workload needs, enabling timely adjustments before performance issues disrupt applications. One subtle limitation is that EBS is tied to a single availability zone. Volumes cannot be attached across zones, meaning replication or snapshots must be used to achieve resilience. Beginners should think of this as keeping valuables in a local safe. If the building is lost, so is the safe. The workaround is duplication, copying volumes or restoring snapshots into other zones or regions. On the exam, watch for this limitation, as it's a frequent trap. Designing with multiple volumes is a common best practice. Separating logs, application data, and root devices across volumes improves performance and resilience. For example, logs can fill one disk without threatening the database volume. Beginners should think of this as having separate drawers for tools, files, and personal items. When one drawer overflows, the others remain intact. Multi-volume design also allows finer-grained scaling and tuning, helping workloads adapt gracefully under stress. Cost optimization remains central to EBS usage. General-purpose GP3 volumes include a baseline of performance, with the option to provision extra IOPS or throughput for demanding workloads. This allows cost-efficient scaling without jumping to IO2 unnecessarily. Beginners should see this as buying a base car model and adding specific features, rather than upgrading to a luxury package you don't need. The exam may present scenarios where GP3 with add-ons is the smarter choice than overpaying for specialized volumes. From an exam perspective, the crucial skill is matching storage choices to durability and performance requirements. If persistence across reboots is needed, EBS is correct. If temporary but ultra-fast space is acceptable, Instant Store fits. If repeatable environments are required, AMIs deliver. Beginners should practice reading between the lines of questions. Phrases like durable, survive stop, or temporary cache are clues pointing directly to the right option. In practice, these same decisions ensure efficient, secure, and reliable architectures. In conclusion, AMIs, EBS, and Instant Store form the triad of EC2 storage and imaging. AMIs provide repeatable starting points. EBS offers persistent and tunable block storage, and Instant Store delivers blazing fast, ephemeral capacity. The skill lies in knowing which tool to apply for each situation, balancing speed, durability, and cost. For learners, the lesson is that cloud building blocks are modular. By selecting the right combination, validating with metrics, and enforcing governance, you ensure workloads run reliably while meeting both operational and financial goals. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.